If a line is tangent to a circle, then the line is perpendicular to the radius of that circle. That means it creates a 90-degree angle. So if we look at this image here, we've got two circles, a small baby circle and a big papa circle, right? Each of those circles have a tangent line that they share. And so let's use that highlighted theorem and kind of explore it. I'm drawing in my 90-degree angles into that section created by the radii, the tangent line, and the distance between the centers of the circles. And let's say that the small radius is 8, the big radius is 12, and the distance between the centers is 18, and I want us to find the length of the tangent. All right. So here's how you want to approach these problems. You see how we've got a quadrilateral in the center? We're going to break that quadrilateral up into two shapes, a rectangle and a right triangle. And to do that, I'm going to construct a perpendicular line from the center of the small circle over to the opposite side. All right, so here's the two shapes that are created, the rectangle at the top, the right triangle at the bottom. Now, when you draw in that perpendicular line going from the small circle over to the other end, go ahead and draw in the 90-degree angle because that's going to be super helpful with identifying what parts are the legs and the hypotenuse for the right triangle. We'll need that in a little bit. For now, let's label everything we can. Let's start with the rectangle. For rectangles, opposite sides are congruent, so this side is equal to x and this side is equal to 8. Now, we only got one more thing that we need to label here. It's that teeny tiny section under the number 8. That's going to be equal to 12 minus 8, which is 4. All right, so the only way that we could possibly solve for x with this problem is to use Pythagorean theorem, which says a squared plus b squared equals c squared, right? Now, in Pythagorean theorem, it's super important to understand what A, B, and C represent. A and B represent the legs of the right triangle, and C is the hypotenuse. The legs are the sides that create the 90-degree angle. So for this problem, the legs are x and 4. And the hypotenuse is the side directly across from the 90-degree angle. So legs create 90 degrees, hypotenuse does not. Okay, so now we're going to plug in the information we have. We have x and 4 and 18. Okay, so let's see what we get at the end. Got to simplify some things. We need to subtract that 16 from both sides. And then we'll do the square root of both sides. And let's just round to one decimal place. So x is equal to 17.5. All right, let's do another question similar to this one. I'm going to give you the radius, lengths, and this time I'll give you the tangent, and we're going to find the distance between the centers of these circles. So remember, you want to break up this four-sided shape into two sections, a rectangle and a right triangle. You want to do that by connecting the center of the small circle to the opposite side, so basically constructing a perpendicular line. All right, and just so you can have a reference when we use Pythagorean theorem later, make sure you draw in that 90-degree angle. All right, so now we're going to label some things. It's a rectangle, so opposite sides are congruent. This is 21 and this is 10. Now we just need this small little section. That's going to be 19 minus 10, which is 9. Okay, I'm going to redraw this little baby triangle we've got going on. And remember, in Pythagorean theorem, A and B represent the legs of your right triangle. The legs are the sides that create the 90-degree angle. So for this problem, the legs are 21 and 9. All right, so now we're going to plug this stuff in. 21 squared plus 9 squared equals x squared. And to solve, simplify the right side and take the square root of both sides. Once again, we're going to round to 1 decimal place. So x is equal to 22.8. And that's it, guys. Same process every time.